Hi everyone. So today we will discuss the October 2021 Statistics Paper 2. Question number 1. A research project into food purchases found that 35% of people who buy eggs do not buy free-range eggs. A random sample of 30 people who bought eggs is taken. The random variable capital F denotes the number of people who do not buy free-range eggs. So they are asking you part it, find the probability capital F is greater than or equal to 12. The first thing is, what's the first thing you should do here? You must be able to identify the distribution that you are working with here. What's the model that you are working with? So what's the model? First of all, they say capital F is your variable. They use the letter capital F as the variable. It denotes what? The number of people who do not buy. Who do not buy free range eggs. Okay, so then what does F follow? F follows a what distribution? Now you know this is definitely something to do with discrete because you can see there are 30 people here. You have to make a decision whether you are going to go with binomial or Poisson. So what are you going to work? They say here research project into food purchases found that 35% of people who buy eggs do not buy free range eggs. So they have given you the proportion of people who don't buy free range eggs. Also, they have given you a random sample of 30 people, meaning they have given you how many people that they are using for this. Can this be Poisson? Do we have a fixed rate in a given interval? No. So you can see we have a fixed number of trials. There are 30 people here. And the proportion of people who do not buy free range eggs is 35%. So you have the probability as well. So therefore you can say F follows a binomial distribution. The fixed number of trials is 30 and the probability of success or the probability of people who do not buy free range eggs, because that's how we define. Okay, the probability of not buying free range eggs is 0.35, 35%. Are you with me? So in part A, they want you to find the probability F is greater than or equal to 12. So how do we get the probability F greater than or equal to 12? We will use the cumulative probability table from the formula book, right? Yeah. So F greater than or equal to 12 will be what? In the formula book, we have the less than sign. So we will go with 1 minus probability F is less than or equal what? If this is 12, it should be less than or equal 11. So these are rules you need to learn in your binomial in the textbook. You learn this in the binomial distribution chapter. Can I know the answer here? So you must go to the binomial distribution table. You must go to the place where n is 30. Go to the probability column 0.35 and go to the x value 11. Okay, how much is the answer? 1 minus 0.6548. Yeah, so how much is it? 0.3452. Okay, so this is from the table. Okay, then part B, they are asking you to find the probability F is greater than or equal 8, less than 15. Okay, how do we find this? Greater than or equal 8, less than 15 means you need to first of all realize this is bar, this is discrete distribution. So when you say less than 15, it means 15 is not included. What value is actually included here? Greater than or equal 8, less than or equal to what? 14, because you know it's discrete and you do not have any values in between. Okay, so how do we get the probability here? So here we need to get capital F, cumulative probability of 14. Isn't it? You can directly get it from the table. If 14 gives you all the probabilities from x equals 0 plus x equals 1 plus x equals 2 until x equals 14. And then what do we subtract it from? Now I need the probabilities from 8 onwards. So I should subtract it from where? 7. If I subtract from 7, I get all the addition of the probabilities from x equals 0, 1, 2, 3 until 7. So from 0 to 7, the probabilities are subtracted from 0 to 40. When you subtract, you get the remaining part from 8 to 40. And I know the values here. This is again from the table. So from the table, n is 30, probability value 0.35, x value 14. How much is it? 0.9348 minus F7, 0.1238. Subtraction answer 0.8110. Is that okay? Yeah, so actually I use capital F here to denote cumulative probability, but since capital F is also used as a variable here, shall we write it in a better way? So what we'll write here is, we'll write cumulative probability is the probability less than or equal to that certain value, right? So our variable is capital F less than or equal 14. I subtract with the probability capital F is less than or equal 7. Okay, and then we take the probability values from the from the Poisson table, from the binomial table over here, right? Okay. Then let's move on to the next part. A farm shop gives 3 loyalty points with every purchase of free range eggs. Okay, so they give 3 loyalty points with every purchase of free range eggs. With every purchase of eggs that are not free range, the farm shop gives 1 loyalty point. A random sample of 30 customers who buy eggs from the farm shop is taken. Find the probability that the total number of points given to these customers is less than 70. Okay, so let's think about this. What are they saying here? Okay, so now what do we now we know in the question we define the number of people who do not buy free range eggs are what? The number of people who do not buy free range eggs are that's F number of people do not buy free range eggs. So how many people buy how many people are there who do buy free range eggs? Now we know there's a random sample of how many customers? 30 customers. Out of 30 customers in part C, out of 30 customers, capital F amount do not buy free range eggs. So if these people do not buy free range eggs, out of 30, capital F do not buy free range eggs, then how many of the customers will actually buy free range eggs? You have 30 customers. Out of 30, say 10 people didn't buy free range eggs. Then how many are buying free range eggs? 30 minus 10, right? So likewise in here, capital F is the number of customers out of 30. Capital F is the number who do not buy free range eggs. Then how many of them buy free range eggs? 30 minus F. Okay, so then let's what the points. Okay, how are the points given? So the F and 30 minus F. 30 minus F is the amount who buy free range eggs. This is the amount who doesn't buy free range eggs. So shall we calculate the points? How do we calculate points? The farm shop gives 3 loyalty points for every purchase of free range eggs. So which one gets 3 points? The 30 minus F customers, each customer gets 3 points. So if I want to get the total number of points, I should multiply this by 3, right? Then I get the total number of points earned by these customers. And then the customers who do not buy free range eggs, they get 1 loyalty point, which means I multiply this with 1. So then what's the total number of points? To get the total number of points, I just need to add these two, and what needs to be, what's the requirement here? Find the probability that the total number of points given to these customers is what? Less than 70. So you have to find the total number of points should be less than 70. You have to find this probability. Find this probability. Are you with me? The probability that the total number of points is less than 70. So all you have to do here is to solve this equation. So what do we get here? F into 1 is F. 30 into 3 is 90 minus 3F. Less than 70. So we get here 90 minus 2F. Less than 70. Is that okay? So I get here probability 90 minus 70. Less than 2F. 90 minus 70. 20. So basically I get F is greater than 10. F is greater than 10. Let's write it in the way that we are familiar. F, the mouth is open towards F and F greater than 10. So how do I get the probability F greater than 10? F greater than 10, we need to use the cumulative probability table. F greater than 10, in other words, is 1 minus probability. F is less than 9? No, it's greater than 10 means less than or equal 10 because the equal mark is not there. Okay, are you with me? So go to the binomial tables, go to n value 30 and go to the probability value 0.35, right? 0.35 is this column, the 4th column before the last. In there we have to go to 10, right? 10. This is the answer 0.5078, 0.5078. Okay, find value 10. So 1 minus 0.5078, how much is it? Subtract, how much is it? 0.4922. Is this clear? Okay, moving on to the next part. Okay, yeah, next part. The manager of the farm believes that the proportion of customers who buy eggs but do not buy free-range eggs is more than 35%. Okay, in a survey of 200 customers who buy eggs, 86 do not buy free-range eggs. Using a suitable test and a normal approximation, determine at the 5% level of significance whether there is evidence to support the manager's belief. State your hypothesis clearly. Okay, so basically it's a hypothesis test, and you can see here they have increased the sample size. Earlier we had 30 people, now we are working with 200 people. Are you hearing this? And then they have given you the value here. 86 is the value. You have to check whether the value of 86 falls to the critical region. That's what you should do. First thing is, let's write the hypothesis. Okay, in part D. First of all, shall we introduce a new variable? So what's the variable? Y is, because the thing is now we can give a new variable. We used previous letter F, right? Shall I give letter X? So X is the number of customers who do not buy free range eggs. Who do not buy free range eggs. And then what does X follow actually? X follows a binomial distribution, right? And how much is the n value? Now we are n is 200 and the probability is still 0.35. Actually, before we do this, we should write the hypothesis. Shall we write the hypothesis? What's the hypothesis? H naught is probability equal 0.35. You know, in H naught, we always write the hypothesis with the equal mark. H1 has three formats. Either P is not equal to 0.35 or P greater than or P less than. So in here, they say very clearly what? The manager of the farm shop believes that the proportion of customers who buy eggs but do not buy free range eggs is more than 35%. So he clearly says that it's more than. Therefore, we need to test it with the hypothesis. He believes that the probability might be more than 35%. So then let's write the variable. So we know X follows a binomial distribution with n is 200. Probability of success under the fact that H naught is true, 0.35. So you know you're supposed to use the approximation. So and they have told you very clearly you had to use a normal approximation. So nothing else to check here. We had to use a normal approximation. Shall we get the mean? How much is mean? Mean is NP. Calculate 200 into 0.35. How much? 70. And the sigma square. NP 1 minus P. So 200 into 0.35 into 1 minus 0.35. How much is it? How much is it? 45.5. So you can say here Y follows a normal distribution. Mean is 70. Probably the standard deviation is variance is 45.5. Sigma square, okay, is 45.5. So sigma is the root of 45.5. Okay, now let's check the hypothesis. Now, so what's the critical value that you're checking here? What's the value? You are checking against the value. What you need to check now? They have said in a survey of 200 customers who buy eggs, 86 do not buy free range eggs. So basically, we have to check whether this value 86 is the deciding value. You have to see whether this 86 value falls inside the critical region or not. Okay, so you know you are checking for greater than side, right? Greater than side means in the distribution, you are checking the left corner. So you have to see whether the value 86 falls into this tail. So then what probability are we checking? Y is greater than or equal 36, what was it? 86, right? This is what we are checking against. Do you agree with me? Y is greater than or equal 86. Do you agree? Because we are checking whether this value 86 falls to the critical region. The reason I'm going for greater than or equal is because in my H1, we are checking for the right side tail. Therefore, I need to check whether it falls inside the whether it falls inside the 5% in the right side tail. So therefore, right side tail, I will go for Y greater than or equal. If it's the left side tail, we go for less than or equal. Okay, so let's get the probability. Now, before you go to do any probabilities, you know, you are doing from binomial to binomial to normal. You are doing an approximation. So when you're doing the approximation, there is a very important thing to do here. What is it? Before you go to directly work with normal here, you must apply what? Binomial is discrete, normal is continuous. When you are jumping the line, the boundary from discrete to continuous, you must apply continuity correction. So what happens under the continuity correction here? Y is Greater than or equal 86 means when you apply continuity correction, do I go for 86.5 or do I go for 85.5? Do I go for greater than 86.5 or greater than 85.5? 86 is supposed to be included. Okay, so if I go greater than 86.5, 86 will not be included because we have the equal mark here. 86 is supposed to be included. So I need to go with y greater than 85.5. Are you with me? Okay, so now we can go for the normal distribution. So you have to get this probability by using the normal distribution. So let's get it. Probability y greater than 85.5. So y becomes z. So to make it standard normal, we subtract from the mean and divide by sigma, not by sigma square. You divide by sigma, which means root 45.5. So you can do this, the probability, you can get it directly from the calculator. Even the binomial probabilities could have been calculated. Okay, let's get this. Okay, so normal distribution. If you go for P, you get the area behind, isn't it? In normal distribution in the calculator. If you're using the calculator, you need to know how to use it. P gives you the area behind the Z value and R gives you the area in front. I want Z greater than, right? So I'll go for the third one, R. I think it's best that we, shall we find this value first? 85.5 minus 70. 85.5 minus 70 divide by square root of 45.5. Are you with me? So we'll get the value 2.29787. This is okay. So we get 2.29787 and then we'll get the probability from the calc. Okay, so different calculators have different procedures of getting this. So in this one that I'm using, so here I'll give R because R is giving you the probability greater than. So R and I'll give answer here because directly the answer is stored in the calculator. So I get 0.01078. Okay, so which is what? The percentage wise, this probability is 1.078%. And then what do you understand? Now, you know, your critical region is 5%. We have a 5% stake. And 1.078% is definitely falling what? Inside or outside this critical region? It is inside the critical region. So this is less than 5%. Thereby, what does it mean? It is inside the critical region. In the critical region. So 86 is a value in the critical region. What does it mean? There is sufficient evidence, or there is evidence, you can just say, to reject H0. So is this all? Is this all the statements that we are writing? Is that all? You have to say something about the manager's belief. Now, what does the manager believe? The manager believes that the the proportion of customers who do not buy free range eggs is more than 35%. So when our value falls to the critical region, we have sufficient evidence to reject H0. When we reject H0, it means we go with H1, right? So manager also believes that the proportion is more than 35%, which means H1. So when we reject H0, so what happens? Are we supporting? Is there evidence to support the manager's belief? Yes, we have, because we are going with H1. H1 is the manager's belief. So you can write, there is evidence to support the manager's belief. Make sure you give this statement because you have to give a statement with regards to the claim. There is evidence to support the manager's belief. Okay, or the proportion of customers who do not buy free range eggs is what? More than 35%. So because we reject H0, so we go with H1. Is this clear? So this is the end of the first question. Okay, moving on to question number 2. They say the continuous random variable x is uniformly distributed over the interval AB. Given that probability x greater than 8 less than 14 is 1 over 5 and expected value is 11. Okay, first of all, when we draw this diagram, so you have your interval in between A and B, right? So you have the uniform distribution in between A and B. So this is how we normally define 1 over B minus A is your effect, isn't it? Okay, now they have told you, they have given you the probability. Now you know the total probability under the rectangular graph is 1. They have told you the probability for x value between 8 and 14 is 1 over 5. So you only have 1/5 of the area. Okay, the remaining 450 is outside. Now the problem, the biggest issue here is we don't know the limits. We don't know what is A, we don't know what is B. However, they say here, now they're asking you to write the probability x is greater than 14. Okay, so we have somewhere in between this, there's 8, there's 14, and we are supposed to find the area after 14. But the issue now, it's just 1 mark. Now, do you see, it's just 1 mark, which means it shouldn't be a lot of work. Should be very obvious. Okay, so what you need is look at here is look at the mean value. Now, you know, in a rectangular distribution, it's a symmetric distribution, right? So the mean will definitely be equal to the median, which means your mean will fall exactly in the middle. How much is the mean here? 11, which means you need to realize 11 is exactly the middle value. Your mean is 11. And then when you look at 8 and 14, now 8 and 8, between 8 to 14, you have 1/5 of the area. Can you just check the middle of 8 and 14? Add 8, add 14 and divide by 2. Add 8 plus 14 and divide by 2. 8 plus 14 is how much? 22. 22 divided by 2 is 11. So do you realize that 8 and 14 are equally distant spaced, equally apart from 11? So 8 is like over here, 14 should be over here, equally spaced. Are you with me? And 11 is exactly in the middle of A and B. 11 is exactly in the middle of A and B. So then you have this area. So this is the area that they've given you as what? 1 over 5. So if this area is 1 over 5, what do you have to say about the remaining area? 1 minus 1 over 5 is 4 over 5. So out of that 4 over 5, half of it comes to the more than 14 side, half of it comes to the less than 8 side. So you get this side area 2 over 5, the other side area 2 over 5. Why is this happening? Because 11 is exactly in the middle and 11 is exactly the middle of 8 and 14 as well. Do you realize what's happening here? Thereby 1 over 5 here, when you do 1 minus 1 over 5, it's 4 over 5. The 4 over 5 area is equal distributed after 14 and before 8. So basically the answer for part A, x greater than 14, you don't need to draw anything or show here, but just write 2 over 5 and that's all. You just need to write 1 over 5, 2 over 5. This working is not necessary. This is what we think inside our head. This is the thinking process. What I told you is the thinking process. Part B, they're asking you to find the probability 6x is greater than A plus B. So 6x is greater than A plus B. The first thing is, shall we get the A and B values? I think you know we can get it right. Can you all get the A and B values here? How do we get the A and B values? Okay, so how do we get the value of A and B? Now, do you realize in this entire rectangle, the width is common to everywhere, right? It's the same width you have. Now, do you see in between 8 to 14, the area was 1 out of 5. And do you see between A and 8, the area is 2 out of 5. 2 out of 5 means the area is double. So when the area is doubling, now you know it's the area of the rectangle is length into width, right? Now my drawing might be a little bit misleading here, but okay, so let me make it a little bit clear. So you realize your area is doubled, right? Okay, so it's more than, it's double of this area. Now, you know, your width is not changing. So then what is changing? It's only the length that has the effect that can make double the area, right? So what does that mean? Now 8 to 14, how much of a gap do you have? Okay, 14 minus 8, you can get a gap of how much? 6. 14 minus 8, there's a gap of 6 in between. Now, Since the length is double, you need to realize your length is what doubles over here. That's why the area gets double, because the width is constant. Thereby, this width should be double of that width. From 8 to 14, you have a width of 6. So from 8 to A, we should have a width of how much? 12. That's how you can get double the area, because the width doesn't change. Similarly, over here also for 2 over 5, you need to realize what? I'll make it a little bit longer just to make it more realistic. So you need to realize, okay, you need to realize that the width is double, the width is, the area is double. So area of the rectangle is length into breadth. Length into breadth, and here the breadth doesn't change. It's the length that changes. So the length has to be double of this length over here in order for the area to be double. Because this is a uniform rectangle, right? The 1 over b minus a is the width of the breadth of the rectangle. That is constant. The breadth of the rectangle, all these 3 rectangles are exactly having the same breadth. That doesn't change. 1 over b minus a. Do you realize what's going on? So for the area to be doubled here, it's the length that has to double. So which means this gap should again be a 12. So can't you get the a and b values here? A is going to be 8 minus 12, right? How much is it? Minus 4, and B is going to be 14 plus 12, which is 26. So now input the values and let's get the area probability. 6x is greater than A plus B. A is minus 4, B is 26. How much is it? Probability x is greater than minus 4 plus 26 is 22 over 6, right? Is this correct? Can you all simplify? How much is 22 over 6? Simplify the answer. 11 over 3. Okay, so you have to get the area greater than 11 over 3. Basically, the area of the rectangle. So you know your uniform distribution rectangle starts at minus 4, goes until 26. So you have to get the area greater than 11 over 3. 11 over 3 is somewhere over here. You have to get this area. Are you with me? What's 1 over b minus a? You'll have to get the value of 1 over b minus a. Who is that? 1 over b is 26 minus a is minus 4. How much is it? 1 over 30. So length into breadth. Now we know the width of the rectangle is 1 over 30. So it's 1 over 30 multiplied by what's the width here? The length of the rectangle. I'm sorry. The width of the rectangle is 1 over 30. It's 1 over b minus a. The height of it, the height of the rectangle. The length is 26 minus 11 over 3. How much is it? 67 over 90. This is the answer for part B. 4 marks. Is this clear? Okay, Roman number 2, they say Susie makes a strip of pasta 45 centimeters long. She then cuts a strip of pasta at a randomly chosen point into 2 pieces. The random variable S is the length of the shortest piece of pasta. And you see, they have defined S to be what? S is the length of the shorter piece. Because when you divide your pasta piece, it's 45 centimeters, you cut it at a random point. When you cut it at a random point, one piece will be generally short, the other one should be longer. So they say S is the length of the shorter piece. They are asking you to write down the distribution of S. So when you cut it into 2, the shorter piece, where do you think the shorter piece is going to lie, the lengths? It's going to be, the shorter piece length will lie in between what and what range? Now your whole length is 45. The shorter piece is going to be what? It's going to be less than half of this 45, isn't it? So you can see here, S follows a what distribution? Do you think we have binomial here, Poisson here? This is uniform. It's again uniform, and your shorter piece could be anything in between 0 to, what's the middle of 45? 22.5. Are you with me? So your shorter piece has to always be between 0 and 22.5. Do you agree with me? Okay, so write down the distribution. This is one way of writing it, or you could say part B, you can write like this. F of S is 1 over B minus A, right? 1 over B minus A is 1 over 22.5. Can I know how much is 1 over 22.5 in simplest form? Because it's 1 over B minus A. 1 over 22.5, 2 over 45. So your Fs value will be 2 over 45 for S values between what and what? 0 to 22.5. 0 otherwise. Okay, we'll remove the equal sign. S is between 0 and 22.5. Okay, this continuous distribution, you know that the equal mark does not make a big impact here, right? Okay, then the next part they say, I mean, you could write this as well here, okay? Both of them. Writing actually one of them is enough. Okay, because it's simply one mark, you don't need to write all of this. Even if you just define it's a uniform distribution between 0 and 22.5, it would be more than enough. Okay, so I just wrote this as extra information, but you don't need this. Basically, this answer is more than enough for 1 mark. Okay. Part C. Sorry, this is part A. Roman number 2 part A. Now only I'm going to Roman number 2 part B. I got 2 over 45 because I was using 1 over B minus A here. 1 over B minus A, 1 over 22.5 minus 0. When you type in the cal 1 over 22.5, it's 2 over 45. Okay, now let's go to Roman number 2 part B. Calculate the probability the shortest piece of pasta is less than 12 centimeters, which means what's the probability? We have to find S is less than 12. Can't you find this probability? So we already have the distribution. The distribution is between, S values are between 0 and 22.5. This is this is 2 over 45, right? 1 over B minus A is the height of your rectangle. So they want to find the probability S is less than 12. To find the area of this rectangle. So how do we get it? Length into breadth. 2 over 45 multiplied by 12 minus 0, right? Can I know the answer? 8 over 15. Okay, shall I move to the next part? Part C. So C makes 20 strips of pasta, all 45 centimeters long, and separately cuts each strip of pasta at a randomly chosen point into 2 pieces. So they say here very clearly she makes how many strips? Clearly they say there are 20 strips. Each of these strips are 45 centimeter long, and every strip she can randomly cut it at a chosen point into 2 pieces. Calculate the probability that exactly 6 of the pieces of pasta. Okay, are you following the question? 6 of the pieces of pasta. 6 pieces of pasta out of how many? Out of 20 pieces. Out of 20 strips. Out of 20 strips, they want exactly 6 pieces of pasta are less than 12 centimeters long. So what do we do here in part C? What kind of a probability do we have? What is the random variable in part C? Part C, let's give a new variable. We use the letter S here, right? Shall we use the letter X? X is what? So we'll say X is now what? X is the number of strips of pasta. Number of strips of pasta. It's really important the way you define this. X is the number of strips of pasta less than 12 centimeters long. X is the number of strips of pasta less than 12 centimeters long. So X follows the what distribution? Is it uniform? When you have counting the number of strips, now you are counting, right? The number of strips, you have 20 strips. So definitely this is not continuous. This is discrete, and you have to go with what? There are 20 strips of pasta. There's a fixed number here. So basically it's binomial. N is 20. What's the probability of success? Probability of success is that the pasta is less than 12 centimeters. So what's the probability it's less than 12 centimeters? It's 8/15. The answer we found in part B. So then using this, we have to find the probability that exactly 6 pieces. So basically, we have to find the probability x equals 6. So get the probability x equals 6. Can we use the binomial tables here? No, I think 8/15 is not a value you will get in the binomial table. So you will have to work on it manually. So you only have a single x value to find. So you can do it easily. 20c6 ncx p to the power x 1 minus p to the power n minus x, right? So p is 8/15 to the power x, which is 6. 1 minus p. So 1 minus 8/15 to the power n minus 6. 20 minus 6. So it's a matter of typing this in the calculator. 20c6 into 8/15 to the power 6. Okay, this mode. 20c6 into 8/15 to the power 6 into 1 minus 8/15 to the power 20 minus 6. Are you with me? So we get 0.0207. 0.0207. Is this clear? Okay, moving on to question number 3. They say a continuous random variable x has cumulative distribution function, and they have given the capital Fx, right? The cumulative function. There are two functions here. 4ax square is defined for x values between 0 and 1, and a bx cube minus x to the power 4 plus 1 is defined for x values between 1 and 3. Now they are saying here a and b are positive constants. Okay. Part A show that b equals 4. And how many marks? 1 mark. So 1 mark means it should be pretty obvious. So that when it comes to cumulative, the first thing that comes into my mind is, we know in cumulative, the total probability is what you get at the very end. And what's the very last x value we have here? The ending x value is at 3, right? So basically, I know definitely capital F of 3 should be 1. Capital F of 3 should be 1. So when I go in that path, am I going to get b equals 4? Look at that a here, b times 1 to the power 3. I think no, right? A into b times 3 cubed minus 3 to the power 4 plus 1. I think you can see here we run into a problem. Why? There are two unknowns. We don't know A, we don't know B. So this is the obvious thing we feel, but that doesn't work. The reason it doesn't work because there are two unknowns. A and B are both. I mean, we can't find B when we don't know A. Okay, so then if that doesn't work, okay, so if that doesn't work, what should we do? What other option do we have? What other option do we have? Now, do you see the first function is 4ax square, right? 4ax square is defined for x values between 0 and 1. Okay, so if I take f1 from the first function, from the first one, and the next graph starts from x value greater than 1, right? But however, you need to realize that this is continuous, right? So even over here, if you use capital F1, even over here to this graph, okay, because it starts from 1, even though the equal mark is not there here, you need to still get the same probability, right? Because capital F gives the area behind. Now we start with 1, so that means capital F1 means the area behind 1. So basically, if you use capital F1 here or over here, now you might think, how can we use 1 over here? 1 is not equal, but this is a continuous graph. So you still have 1 over here. We can use it, but I mean, you can't use x value like 0.9, you can't use over here. That you can't do. Okay, because here we start at 1, you can use F1 over here and make the probabilities, the cumulative probabilities equal. Are you with me? So F1 I get here 4a into 1 square, which I get as 4a. Are you with me? From the other graph, I get f of 1 as a times b into 1 cube minus 1 to the power 4 plus 1. How much is it? A times this is b into 1 cube is b minus 1 plus 1 is going to be 0, right? Which means I get a, b here. Are you with me? So make them equate them. The probability, cumulative probabilities are equal. 4a equals ab, which gives me b equals 4. Can you see? So this is the 1 mark, show that. So even though it's a 1 mark, show that the thought process was a little bit longer, right? Because most of you would be like, okay, how do we get it? And you might be having problems by using 1 here, but you can, because we started 1 and it's continuous. You can use 1 over here. Okay, but you can't use x value is less than 1. Like you can't use 0.9, 0.8, anything like that you can't use. Okay, then the next one, part C, find the probability x is greater than 2.25. Okay, how do I get the probability x is greater than 2.25? Probability x greater than 2.25 is equal to what? 1 minus x is less than or equal to 2.25. Or you can say capital F of 2.25. Oh, sorry, we had to do B part. Sorry, part B. Find the exact value of A. Okay, how do we get the exact value of A? So this now we found the B value, right? How do we get the exact value of A? We can now go with the earlier thought process, the one that I cut. Here, capital F3 is equal to 1. Capital F3 equals to 1. Shall we substitute A times B into 3 to the power 3 minus 3 to the power 4 plus 1 equals 1. What do we get here? 27B minus 81 plus 80 is minus 80. B value is 4. Replace. How much is 27 times 4 minus 80? A times 28 equals 1, which gives you A as 1 over 28. Is this clear? So now we'll move to part C. Find the probability x is greater than 2.25. Okay, how do we get the probability x greater than 2.25? So as I was saying to you earlier, probability x greater than 2.25 means the greater area, but you know capital Fx is giving us the area behind. So what I can do is I can do this as 1 minus capital F 2.25. Because when we use cumulative, it gives the area behind. So 1 minus behind area gives the area in front. So when you use 2.25, which range does 2.25 fall? 2.25 is between 1 and 3, right? So you have to use capital F 2.25 for the second range. This guy over here. So we'll use it. 1 minus A is 1 over 28. B was 4 times x cubed. 2.25 cubed minus 2.25 to the power 4 plus 1. Can you see what happened here? I replace A with 1 over 28 and I replace B with 4 and I replace x with 2.25. Can you all type the whole thing in the calculator? Tell me the answer. One minus 0.7476. So what's the final answer? 3SF. 0.252. 2524. Okay, is this clear? Then part D, showing you're working clearly. Sketch the probability density function of x. Okay. So to get the PDF, how do we get the PDF? You have to convert, right? Capital Fx to simple Fx. Differentiation. D by dx of capital Fx gives you the simple Fx. Shall we differentiate? Can you all differentiate? So first of all, capital Fx is 4ax square. Shall we write the value? A is now how much? 1 over 28. 4ax square. Can you all get me the value here? This is 1 over 7x square, right? So what is the simple Fx? So this is for x values between 0 and 1. Yeah, when you differentiate 2 over 7x, is that okay? Okay, next. We'll go for x values greater than 1, less than or equal 3. What do we get? Capital Fx. A is 1 over 28. B is 4x cubed minus x to the power 4 plus 1. Are you with me? So when you differentiate and get simple Fx here, what do we get? 1 over 28 is a constant. You differentiate 4x cubed, we get 12x square minus 4x cubed plus 1 is 0. So you can simplify it. We can take a 4 out. 4 over 28. 4 times 3 is 12. 1 over 7. 3x square minus x cube. Are you with me? So we'll define our PDF. Simple fx is 2 over 7x for x values between 0 and 1, and it's 1 over 7 3x square minus x cube for x values between 1 and 3 and 0 otherwise. Okay, so this is not what we are supposed to do. They want you to sketch it. So shall we sketch this? So when you sketch it, you can see 2 over 7x is a straight line. Okay, so when you sketch y equal to 2 over 7x, let's get the two critical points. We start at 0 when x is 0, y is 0, right? And when x is 1, y is 2 over 7. Just replace x is 0, y is 0. When x is 1, 2 over 7 into 1 is 2 over 7. Are you with me? So that's the first part of the graph. Okay, so the first part of your PDF is going to be between 0 and 1. So this is 2 over 7, right? Okay, then after 1, from 1 to 3, what do we have? We have y equal 1 over 7, 3x square minus x cube. I think it's easy to draw the graph if I factorize it, right? Shall I take x out? No, we can take x square out. What do we get? When you take x square out, I get 3 minus x. Are you with me? So this is a cubic graph. Are you with me? There's a cubic graph. This is a cubic graph, and there's a repeated root at x equals 0, isn't it? So when y is 0, let's get the roots. When y is 0, I get here 0 equal 1 over 7 x square 3 minus x. 7 goes x square 3 minus x. So I get here x square equals 0 or 3 minus x equals 0. X equals 0 is a repeated root, which means you have a turning point at x equals 0, isn't it? Because in a cubic graph, you need to realize if you sketch this individual cubic graph, at x equals 0, you have a repeated root. At x equals 3, there's a single root. So it's a negative x cube graph, right? A negative x cube graph means your graph should come in this manner. Positive x cube graph comes like this, where when x increases, y increases. In negative x cube, when x increases, y is decreasing downwards. Okay, so basically your graph would be a negative x cube graph, right? You see it's negative x cube minus x cube. Can you see it? So that graph should look like this, isn't it? I mean the individual graph, but we had to write it over. We had to draw it over here, and we are only supposed to draw it from 1 to 3. Only from 1 to 3. Okay. Okay. Okay, so this is how the graph looks. But the thing is, you are not supposed to now. This is from 0 to 3, but we need to only draw the graph from 1 to 3. So basically 1 is somewhere over here, right? So we need to only draw the graph in the section from 1 to 3. Can you see? Only this section of the graph needs to be drawn over here. Okay, so when x equals 1, can you replace x equals 1 over here and get me the y value? Because we need to see where it starts. Does it start at 2 over 7, or will it start above, or will it start below? So replace x with 1. When x equals 1, what do we get for y? So 1 over 7 into 1 square into 3 minus 1. How much did you say? Y is 2 over 7. Basically, it starts over here, right? When x equals 1. So when x equals 2 and until now, you have to go until x 2 and 3, right? Over here. So now the thing is to draw the remaining part of the graph from 1 to 3. So you can see the way it's drawn, right? So I think you can see it's slightly going up, because I saw some of you have just drawn like this. This is not accurate, okay? Because you can see in the rough sketch that I drew here between 1 and 3, there's a turning point, right? Can you see? So basically your graph should go somewhat up like this and come down. Okay, so you can check whether this is correct or not. You could input this in the calculator and give some X values to see whether your Y values are rising above 2/7. Okay, so this is roughly how your graph should look. Is this clear? So this is the sketch of your graph. Sketch the probability density function of X. So this is it. Okay. So I just only had to draw this section of the graph. Then moving on to the last part, calculate the mode of X. So mode, what is the mode? Mode is the X value that gives the highest Y value in your graph. Are you aware? So in this graph, I think you can see clearly the mode is at the turning point, at the highest point. So what's the turning point? Can you all get the turning point? Who is the turning point? Shall we find it manually? Y equal 1/7 x square 3 minus x. So I think when we open it, when we expand it, what will we get here? Because I want to find the turning point. Better that we can differentiate and get it, right? 3/7 x square minus x square into x is x cube, 1/7 x cube. Differentiate. I get here 6/7 x minus 3/7 x square. Make it equal to 0 to get the turning points. You will get two turning points here because of there are two turning points in the cubic, but we only need the one between 1 and 3. We'll multiply the whole equation with 7. Is that okay? When you multiply everyone with 7, you get here 0 equals 6/7 into 7 is 6. 3, yeah, power 2. Sorry, this should be power 2. So here we get 6/7 into 7 is 6x minus 3/7 into 7 is 3x square. So you can factorize this. Take 3x out and you get here 2 minus, we get x, right? So we get here 3x equals 0 or 2 minus x equals 0. Basically, x is 0, which is the turning point that we know that comes over here, right? The turning point that comes over here, but it's not considered in our graph. Okay, because we only need the cubic graph from 1 to 3, and the other x value is that x equals 2. So that's it. So this is the turning point x value. The higher, the x equals 0 is the lower point, while x equal 2 is giving you the highest point. So basically the highest point is at x equals 2, which means who is your mode? So your mode equals to, mode is equal to 2. Okay, because mode is the x value that gives the highest y value. So in your graph, in your sketch, you can see the mode is the highest point is over here. So for that, the x value is 2. Is this clear? Okay. Okay, so we'll move on to question number 4. They say here the number of cars entering a safari park per 10-minute period can be modeled by a Poisson distribution with mean 6. Okay, so clearly they mentioned the distribution here. It's a Poisson distribution, so it's a discrete distribution. Find the probability that in a given 10-minute period, exactly 8 cars will enter the safari park. Okay, first things first, shall we define our random variable? So x, what is x? X is the number of cars. So always when you're doing Poisson, make sure when you give the variable, give the interval. Because otherwise when the interval changes, you have to change the variable also. So here, x is the number of cars entering the park, number of cars per 10-minute period. So make sure you give your period. Okay, so x follows the what? Poisson distribution. How much is the mean for a 10-minute period? The mean is 6. So they are asking you to find the probability that exactly 8 cars means x is equal to 8. So to get x equal 8, if you want, you can use the table, Poisson table, and do capital F8 minus F7, right? And then you can get the answer, or you could use the equation. E to the power x, e to the power minus lambda, lambda to the power x over x factorial. So e to the power minus lambda into lambda to the power x over x factorial. Are you with me? How much is this answer? 0.103. 103. 3 SN. I'll see this. Okay, 1033. Okay, part B. Find the smallest value of n such that the probability that at least n cars enter the safari park in 10 minutes is less than 0.05. Okay, first thing is, do we change the interval? The interval is still 10 minutes, right? 10 minutes or less, so 10 minute period. So that means our variable is still x. So they say find the smallest value of n such that the probability that at least n cars. What do you mean by at least? At least n means greater than or equal. So you must know the meaning. So probability x is greater than or equal n. Isn't it? This is equal to what? The probability that at least n cars enter the safari. This is it, right? This is less than. So this should be less than 0.05. Just read the question and write the statement. The probability x greater than or equal n is less than 0.05. You are supposed to find the value of n. Okay, how do we find the n value? So first thing you do here is we can't work with greater than. We need to work with cumulative probabilities. Convert it to less than. So 1 minus probability x is less than or equal to what? When you have greater than or equal n, this should be less than or equal. Will it be n? What do you get here? N minus 1, right? Because if you have greater than or equal, then the less than should be 1 below that, right? So n minus 1 is less than 0.05. Shall we fix it? 1 minus 0.05. I'll bring the 0.05 here. I'll bring the probability x less than or equal n minus 1 over here. Okay, so 1 minus 0.05, 0.95. So probability x is less than or equal n minus 1 equals to is greater than 0.95. So what do we do now? Take the tables. Go to the Poisson tables. Go to the Poisson tables. So you go to your Poisson cumulative distribution function and go to the lambda value 6. And what do we need here? In the question they say the probability x is less than or equal n minus 1 is a cumulative, because x less than or equal means we can use the cumulative table. So that probability should exceed 0.95. So you need to look at the first value who exceeds 0.95. So go through this. Who is the first x value to exceed 0.95? 0.9161, 0.9574. Can you see? So x is 10. Can you see? The probability x is less than or equal 10 is actually equal to 0.95. How much was it? 0.9574. So do you notice that this is the first value of x who exceeds 0.95? So which means what? The n minus 1 is equal to n minus 1 value is equal to 10, because we need to have n minus 1 here. So n minus 1 is what we have as 10 over here, which means n is equal to 10 plus 1, n is equal to 11. Okay, so these are kind of like exercises that you do in the S2 book. You should be familiar with these techniques because it's done in the S2 book. And the next one, part C. Part C, they say the probability that no cars enter the safari park in m minutes, where m is an integer, is less than 0.05. Find the smallest value of m. Okay, now in here you can see definitely what your variable is it the same or is it changing? The variable is changing. Why? Now earlier we defined x variable under a what minute period? For a 10-minute period. So now because it's m minutes, you have to get the new variable. So shall we define in part C? So part C, give me a name. Let's give a letter y. Okay, y is what? The number of cars in m minutes. The number of cars in m minutes. Okay, how do we get? So y follows a Poisson distribution. How do you get the lambda value? You know, in a 10-minute period, what was the lambda value? In a 10-minute period, the mean was 6. So in a m-minute period, what's the lambda? This is the period and this is the rate, the lambda value. Okay. So get the answer. How much is it? Make lambda the subject. You could multiply So I get 10 lambda equals 6m, which gives me m equals 10 over 6, right? Sorry, lambda. We are supposed to make lambda the subject. Lambda equals 6 over 10m, right? Which is 0.6m. So your Poisson distribution has a mean of 0.6m. Are you with me? Okay, they are asking you now what? Find the smallest value, sorry, find the probability that no cars enter. The probability that no cars enter means your y is equal to what? 0. The probability that no cars enter the safari park in m minutes, where m is an integer, is less than 0.05. So the probability that no cars enter in a m minute period is 0.05, is less than 0.05. This probability that no cars enter in m minutes is less than 0.05. They are asking me to find the smallest value of m. Okay, how do we find this? Y equals 0 probability, we can use the equation, right? Shall we? Because it's a single probability value. So how do we open it? E to the power minus lambda, right? E to the power minus lambda into e to the power minus lambda into lambda to the power x over x factorial. This should be less than 0.05. Are you with me? E to the power minus lambda, lambda to the power x over x factorial. E to the power minus 0.6m, 0.6m to the power 0 is, anything to the power of 0 is 1. Divide by 0 factorial is also 1. So I think you can see we can make e to the power minus 0.6 is easily subjected here. And let's use log to both the sides, ln. So minus 0.6m comes forward, ln e less than ln 0.05. So to make m the subject, ln e is 1. So when you take make m the subject, minus 0.6 goes to the other side as a what? Division. So when you take a negative number as a division, what happens to the inequality? The inequality sign will flip. You can see the less than has become greater than, because you're taking a negative number as a division. So what do we get here? Can you all type? The smallest m value if they want. ln 0.05 over minus 0.6. 4.9928. M greater than 4.9928. So what's the integer? Because they say m is an integer. Can you see? The question they tell you m is an integer. Yeah, part C where m is an integer. Can you see? So 4.99. So what's the first integer that obeys this? M equals 5. Is this clear? They're asking you to find the value of m, right? Yeah, so your m value is 5. Okay. Now in part B, they say a car enters a safari park. Find the probability that there is less than 5 minutes before the next car enters a safari park. Okay, again, now did you notice in the previous question, they said less than 10 minutes in a certain question? When you say less than 10 minutes, it was a 10-minute period, right? So here 10 minutes or less, we were working with a 10-minute period. So when they say here less than 5 minutes, find the probability that there is less than 5 minutes before the next car enters. The first thing is you need in Poisson, it's really important before you do anything else to identify your interval, because you have to define your variable according to the interval. So what's the variable here? So definitely you have a 5-minute interval. Less than 5 minutes means it's a 5-minute interval. So in part D, you will give what? You will define a new variable. Give me a new variable. Don't use Z. We'll use W. Okay, so W is what? The number of cars entering the safari park in what? In a 5-minute period. Number of cars in a 5-minute period. And W follows what distribution? A Poisson distribution with how much mean? Mean is 3. A Poisson distribution with a mean of 3. Okay, then they are saying to you, find the probability that there's less than 5 minutes. Okay, we fixed that, the interval. Find the probability that there's less than 5 minutes before the next car enters. Okay, now this is the part you need to find now. Okay, what's the probability? What probability of W are you going to find? Before the next car enters, that there is less than 5 minutes. So what's the value you use here? Probability W is what? What value are you going to use here? Think about it. Okay, so when they use the word before the next kind, we need to really think a little bit about it. So what do we say? Do we say one car, or it could be two, it could be three? There's no end, there's no limit here. So basically, you need to definitely have a car entering. So this is, in other words, what? At least one car. You need to have at least one car entering. Okay, before the next car enters. So at least one car should enter. So it could be two, it could be three, it could be more. Basically, this is W is what? Greater than or equal 1. That's what you need. So you need to read the question and understand. So here that's equal to what? 1 minus probability W is 0, right? Equals 0. So get the probability. 1 minus W equals 0. You could get it from the table, or you could get it from the equation. Shall we get it from one of the two tables? From the table, lambda value is 3, right? Lambda value 3, x equals 0, 0.0498, right? 0.0498. How much is it? 0.9502. Okay, is this clear? So you need to really read the question and especially be able to understand these kinds of statements when they use it. Okay, this requires some experience and practice. Okay, so you need to keep doing as many papers as possible to get this practice. Okay, moving on to part E. Look at this. Given that exactly 15 cars enter the safari park in a 30-minute period. Can you see again what's happening? The interval has changed. Do you notice that what are the intervals we were using previously? First we used 10-minute period, and for 10-minute period we used the variable x. Then we used the which minute period? M-minute period. Okay, that is not necessary. That's not for M-minute interval we use y, right? And then we use less than 5 minutes. 5-minute interval, what was the letter we used? We use W, right? So we'll have to introduce again another new variable for the 30-minute period interval. So tell me capital letter that we can use here. Yeah, capital A is what? The number of cars entering in what period? Number of cars entering in a 30-minute interval. Okay, in a 30-minute period. Can you get the lambda value? A follows the Poisson distribution. For 10 minutes, the lambda value was 6. For 10 minutes, the lambda value is 6, which means for 30 minutes, lambda value is 18. Okay, right. So we define that. And then they say here, let's read the question. Given that exactly. Now you can again see the word given that. When you see the word given that, you need to remember something about given that. What is given that? When you see given that, it's conditional probability. See, I have written the rule, conditional probability rule, just to remind you all. A given B, the given that probability, the given part is behind, and the finding probability part should be written front. A given B. Probability A given B is probability A intersection B over probability of B. Do you remember this? This is a rule you learn in statistics 1. Okay, so given that, it's definitely conditional probability. Given that exactly 15 cars enter the safari park in a 30-minute period. Okay, so when you're doing a given that, remember the given that part comes after the slash. So after the slash, what should I write? In a 30-minute period means my variable is A. How much is A? Given that exactly 15 cars enter the safari park in a 30-minute period. Which means, do you agree A equals 15? Because A is the number of cars entering in a 30-minute period. So they say here in a 30-minute period, 15 cars entered exactly. Then they're asking you find the probability. You know, finding probability is what we should write at the front, isn't it? Find the probability that exactly one car entered the safari park in the first 5 minutes. Okay, first 5 minutes means what? 5-minute interval. Do you remember what was the variable we used for 5-minute interval? We used W, right? Okay, so find the probability that exactly one car entered in the first 5 minutes of the 30-minute period. Okay, how do we do this one? So exactly one car entered the safari park in the first 5 minutes, and then what happens? The remaining 40. Yeah, think about it. Take a moment and think about it. Yeah, Okay, so if one car enters in the first 5 minutes of the 30-minute period, in other words, the remaining 14 cars are entering what? After that, in the remaining 25 minutes. So this 30-minute period is divided over here. So find the probability that one car entered in the first 5 minutes and the remaining 14 cars are entering in the remaining 25 minutes. So again, do you see there's another need now? We need to again define a new variable. What is the new variable needed for? Number of cars entering the park in 25 minutes also needs to be defined. Are you with me? So define that. Let's define it. Okay, so let's define the other variable as well quickly. With what's the variable? B. So B is the number of cars in what? In 25 minutes. And B follows the Poisson distribution. Can you all calculate? For 10 minutes, we have a lambda of 6. For 25 minutes, what's the lambda value? Multiply 10 lambda, 25 times 6. So lambda is 25 times 6 divided by 10. How much is it? 150 over 10, 15, right? So B has a Poisson distribution, which means 15. Are you with me? So this is the lambda value for the 25 minute period. Okay, so then let's try the finding probability here. Now they have told you again, reading the question, they tell you find the probability. Now given that is written at the back after the dash, they say find the probability. Finding probability part should be written at the front. That exactly one car entered in the first 5 minutes, which means WV is 1. And what? WV is for the 5-minute interval, right? And the remaining 14 should enter in the remaining time, isn't it? What's the remaining one? B, right? And B is 14. Are you with me? So W is 1 and B is 14. Given that A is 15. Can you see all these intervals? All these different time intervals are getting different variable names. Okay, so what do we do here basically? So you write your downwards probability A equals 15. On top, what do we write? Probability W is equal to 1 multiplied by probability B is equal to 14. So this is the probability of the first car entering in the first 5 minutes and the remaining 14 cars are entering in the remaining 25 minutes. Over the given that there are 15 cars in the 30-minute period. Is this clear? So let's get it. W equals to 1. So get the answer W equals 1. So I think you'll have to go manually with these things, right? Shall we go manually? To the power minus lambda. What was the lambda value for W? For W, the lambda value was 3. For W, the Poisson distribution lambda is 3. Okay, be careful. Huh? E to the power minus lambda, lambda to the power x over x factorial. In B, what's the lambda value for B? For B, the lambda value is 15. So for B equal 14, e to the power minus lambda, lambda to the power x. Can you see? Lambda to the power x over x factorial. This whole thing divided by A equals 15. Again, e to the power minus lambda. For A, what's the lambda value? For A, the lambda value is 8. E to the power minus lambda. Lambda to the power x is 15 over x factorial. Can you see? Okay, so it's a matter of typing the entire thing. So I'll give brackets and type it. E to the power minus 3 into 3 to the power 1 over 1 factorial. 1 factorial is 1. Multiplied by, the brackets are actually not necessary, but I'm typing it as a, it's not necessary actually, to the power minus 15, just so that it becomes clear to you all. 15 to the power 14 over 14 factorial. Is that okay? Divided by e to the power minus 18 into 18 to the power 15 over 15 factorial. Can you see the way I typed everything in the calculator? So I get 0.1947. Zero 0.194716, basically 0.195. Correct to three significant figures. Is this clear? Okay, so this is the 4-mark the given that question. So you need to be more careful here because there are different intervals of time. So for each different interval of time, you have to introduce different variables and do the sum. Okay. So moving on to the last part. Aston claims that the mean number of cars entering the safari park per 10-minute period is more than 6. Okay, so in a 10-minute period, he says that there are more than 6. Now, actually, what is 6? If you remember, in a 10-minute period, the lambda value was 6, right? So in a 10-minute period, the lambda value for the 10-minute period was defined as 6. Can you remember here? The number of cars in 10-minute period was 6, the mean value. So Aston says that this value is actually more than 6. Then to test his claim, what he does is he selects a 15-minute period. Okay, he doesn't work with the 10-minute period. He selects a 15-minute period at random in order to test whether there is evidence to support his claim. Okay, so if you're working with his claim, the first thing is we need to now you realize that his claim is that the lambda is more than what is stated, right? So you get it. So in a 10-minute period, the lambda is more than 6, which means what is generally trying to say is that the lambda value that we assume that we get by the interval or the real value, he claims it's more than that. Okay, so then what's the lambda value for 15 minutes? I think the lambda value for 5 minutes was 3. So lambda value for 15 minutes period should be 9. Shall we give a new variable? Variable C, number of cars in 15 minutes. And C follows the Poisson distribution with mean 9, right? And then what does he claim? His hypothesis is H0 is lambda equal 9. They haven't asked you to write the hypothesis actually. So you don't need to, but you can have an idea of what's going on. So what's happening here? H1 is lambda greater than 9 because generally his idea is that the lambda value is more than what's stated. Then you are supposed to what? They are asking you to determine the critical region for the test at 5% level of significance. So for the 15-minute period for the lambda value of 9, they want you to find the critical region. So critical region lambda value greater than 9 means you realize you have to check at the right tail, isn't it? The one tail test. So let's get the probability. So if this is nearly 5% over here, this area over here should be 95%. So let's get the table. Get the table, and I think the inside the critical region should be the first value that exceeds 95%, right? Behind area is 95%. So if you want to get the value inside the critical region, the cumulative probability should be more than 95%. Do you agree with me? So lambda equal 9. So for lambda equals 9. Yeah, what do we get for lambda equal 9? Who is the first one that exceeds 0.95? 0.9585 is 14. So anyway, you have to do the working and show. This is 0.9261 is 13, right? Can you all tell me both of that? Now you are testing for greater than. Remember, you're testing for greater than. So you should write here what? X is greater than or equal 15 because what you got here was in the table you got 14, right? In the table you got 14. Am I correct? 9585. Okay, so get this 15. 15 is 1 minus x is less than or equal 14, right? Because you have to get the value, the critical region. Like you have to see from where the critical region starts. What's 1 minus probability 14? 0.9585. How much is it? 9585. How much is it? 0. 0.0415, so which is 4.15%, which is less than 5% and inside the critical region. Also check the other one and also show x is greater than or equal 14, right? Because 15 is inside and you have to just show one value inside the critical region and the other one immediate neighbor who is outside. 1 minus x is less than or equal 13, right? How much was that? X is less than or equal 13 was 0.9. I just showed it, right? 9261, I just showed it, right? For lambda value of 0.9261 for 13. Can you see? When you subtract, what do we get? 0.073, which is 7.39%, which is what? Definitely greater than 5%. It exceeds, and it is definitely what? Inside or outside the critical region? It's outside. Then what's your critical region? Actually, it's not x, right? The variable I used was letter C. So we need to give that letter in that order. C is greater than or equal 15. So that's your critical region. Is this clear? Question number 5. A bag contains a large number of counters. 40% of the counters are numbered 1. 35% of the counters are numbered 2. 25% of the counters are numbered 3. Okay, are you with me? So with the variable, there's 1, 2, and 3. Probability of 1 is 40%, 0.4. Probability of 2 is 0.35. Probability of 3 is 0.25. Okay, so what are they saying here? In a game, Alif draws 2 counters at random from the bag. So there's a large number of counters, right? So this gives the respective chance of getting each counter. So they say in a game, Alif draws 2 counters at random from the bag. His score is 4 times the number on the first counter minus 2 times the number on the second counter. So 4 times what you get first. So first counter number will say x1, the first drawing. Subtracting with 2 times the number on the second count, x2. x2 is the second counter. Okay, so then they're asking you show that Alif gets a score of 8 with probability 0.0875. It's just 1 mark. So basically you have to figure out what's your x1, x2. Now you need to realize your x1, x2 comes from what? It comes from these x values, right? From the table over here. So x value can be 1 or 2 or 3. Okay, so now you need to decide in which order. What's your x1 and what's your x2? To get a score of what? 8. So what should we use for x1, x2? So obviously to subtract and get a positive answer, definitely x1 should kind of maybe be larger. Okay, so which one? How do you try? For x1, we'll try with 3. 3 times 4, 12. Minus 2 times what? 2 times 2 is 4, right? 4 times 3, 12. Minus 2 times 2 is 4. 12 minus 4 is 8. Can you see? 3, 2 combination works. Can I reverse that combination? 4 times 2, 8. Minus 2 times 3, 6. 8 minus 6 is 2. That doesn't work. Because I need to get a score of 8. So is there any other combination that gives me 8? If your x1 is 2. So 4 times 2, 8. Minus 2 times 1 is 2. 8 minus 2 is again 6. So I think, no, it doesn't work, right? 3 and 2, we tried 3 and 1 should not work. 3 times 4 is 12. Minus 2 times 1 is 2. 12 minus 2, 10. So it doesn't work. You just need to input values for x1, x2 here so that you get a value of 8. Are you with me? 2 times 4, 8. Even you can use x1, x2 as 2. 2 times 4 is 8. Minus 2 times 2 is 4. 8 minus 4 is 4. So no, it doesn't work. There's only one combination, and also you don't need to think so much because it's just 1 mark. So it should come with this combination quite easily. So what's the probability of getting a counter with number 3? Counter with number 3 probability is 0.25, right? counter with probability, counter with number 3, the probability is 0.25. Multiplied by the counter with number 2 is 0.35. Multiply 0.25 into 0.35. Do we get the answer? Yes, right? 0.0875. So this should be more than enough. Is this clear? Okay, part B, they say ask you find the sampling distribution of Alif's score. Okay, so you have to get the sampling distribution of its score, which means what? You have to show all possible samples and the scores. Shall we do it? Okay, so let's get the sampling distribution part B. Let me draw it over here. So x1, x2, and the score. Score is 4x1 minus 2x2 is the score and the probability. So this is the table that we need to fill. Okay. Okay, so what's x1? So now take all possible combinations. Okay, take all possible combinations. X1 we can take. We'll start with 1, right? 1 and x2 is also 1. 1, 1. So for 1, 1, what's the score? 4 times 1 is 4. Minus 2 times 1 is 2. So 4 times 1 minus 2 times 1. The score is 2. So probability of getting 1 twice is 0.4 into 0.4, which is 0.16. Okay, next one. Take all the possibilities. 1 and 2. So 1 and 2, it's 4 times 1 minus 2 times 2. Are you with me? How much is it? 4 times 1 is 4. 2 times 2 is 4. It's 0. So the probability of getting score of 1 is 0.4. Can you see x equal 1 probability 0.4? X equal to probability 0.35. How much is it when you multiply? 0.14. And the next one, with 1, we can go 1 and 3. So 1 and 3, 4 times 1 minus 2 times 3. 4 times 1 is 4, 2 times 3 is 6, 4 minus 6 is minus 2. Score 0.4 multiplied by 0.25. How much is the answer? 0.1. Okay, so we are done with 1. Now we'll go with 2. So starting with 2, x1 is 2, x2 is 1, 2 and 1. 4 times 2 minus 2 times 1. How much is it? 4 times 2, 8 minus 2 times 1. 8 minus 2 is 6. Probability of 2 is 0.35 into probability of 1 is 0.4. How much is it? 0.14. Next one, 2 and 2. That's 4 times 2 minus 2 times 2. 4 times 2, 8. 2 times 2, 4. 8 minus 4 is 4. Probability of 2 is 0.35 multiplied by 0.35. How much is it? Next one, 2 and 3. So 4 times 2 minus 2 times 3. How much is the score? 4 times 2, 8. 3 times 2, 6. 8 minus 6 is 2. So probability of getting the score of 2 is 0.35 into 3 is 0.25. How much is it when you multiply? Zero 0.35, 0.25. How much? 0.08. Okay, so I'm done writing with 2. Next, 3 and 1, right? 3 and 1, 3 and 2, 3 and 3. That's it, right? This is the distribution. Three and 1, so 4 times 3 minus 2 times 1, 4 times 3, 12 minus 2 is 10. 3 and 1.25, into 0.4. How much is it? 0.25 into 0.4 is 0.1. 3 and 2. I think 3 and 2 we already did, right? 3 and 2, the score was 4 times 3. 2 times 2, the score was 8. And this was 0 0.25, 0 0.35, 0 0.0875. And the next one, 3 and 3. 4 times 3 minus 2 times 3 is how much? 12 minus 6, which is 6. 3 is 0.25 into 0.25. How much is it? 0 0.0. Okay, so we are done. And now let's write the table for the scores. So have they given us any name for the score? Okay, so we'll give it a name. Y equals the score. Okay, so the score is capital Y. So we'll make a table for simple Y. What are the simple Y values we have over here? Different values. We'll go in order. Smallest score we have here is -2. After -2, the next score we have is 0. Next one, +2. Next one, +4. Next one, 6, 8, 10. That's all, right? Okay, so for -2, what are the probabilities? For -2, there's only one, right? The probability was 0.1. For 0, there's only one, which is 0.14. For 2, there are 2, right? For 2, the score of 2, there are 2 possibilities. We'll add them, 0.16 and 0.0875. Yeah, what happens when you add 0.16 is 0.0875? Can I know the answer? 0.2475. Okay, when x equals 4, we have only one, which is 0.1225. For x equals 6, we have two possibilities, right? So you have to add the probabilities of both of these possibilities, 0.14 with 0.0625. How much is it? 0.2025. And then when x equals 8, there's only one possibility, which is 0.0875. For x equals 10, also there's only one possibility, which is 0.1. Okay, so is this clear? Yeah, so this is the sampling distribution of Alif's score, 5 marks. Part C, calculate Alif's expected score. How do you get his expected score? This is quite easy. How do you get the expected? EY here. In this case, the score is Y. So EY is you multiply -2 times 0.1 plus 0 times 0.14 plus 2 times 0.2475 plus 4 times 0.1225 plus 6 times 0.2025 plus 8 times 0.0875 plus 10 times 0.1. How much do we have here? Multiply. Be really careful when you're multiplying. Check the figures you're typing in the calculator. There should not be any error. Zero into 0.14 is 0. 2 into 0.2475, 4 into 0.1225, 6 into 0.2025, 8 into 0.0875, plus 10 into 0.1. Yeah, 3.7. 3.7. Is this clear? So that is Alif's expected score. Okay, question number 6. The continuous random variable y has probability density function fy given by. Okay, you can see your PDF has how many sections? There are 3 sections, right? 3 sections. Sketch the probability density function fy. Okay, let's quickly sketch it. So what are the parts we have here? I think you can see the first one, 1 over 14 times y plus 2 is a straight line, isn't it? It's a straight line. 3 over 14 is also a horizontal line. Straight line, but horizontal. 1 over 14, 6 minus y is also a straight line. So basically to draw a straight line, all you need is the 2 coordinates. So we can get the starting point and the ending point. The easiest thing to do here in this graph is, so we take fy equals 1 over 14 times y plus 2. Okay, so input the values. So this is for y value between -1 to +1. Again, continuous. Thereby, what should we do? Input the value -1 and +1. Get me the y values when the x value is -1 and +1. So actually, the y value here is the x value, right? The x value. And then fy is the y value. Can you all input? Type in the calculator. 1 over 14 times -1 plus 2. How much is it? It's 1 over 14. The other one, 1 over 14 times 1 plus 2, which is 3 over 14. So these are the 2 coordinates, the ending point of your line and the beginning point and the ending point. Can you understand? Then the next part of the graph, do you see at from 1 to 3 that you are continuing at 3 over 14? Can you see from 1 to 3, you are maintaining a horizontal line 3 over 14 because if y equal 3 over 14 is a horizontal line. Okay, and then we'll continue from 3 to 5. So y values from 3 to 5. The fy function is 1 over 14 times 6 minus y. Can you all input the value 3? F3 is how much? F5 is how much? F3 is 1 over 14, 6 minus 3. This is 1 over 14, 6 minus 5. Can I know how much these values are? 3 over 14 and okay, so then let's draw the graph now. Okay, starting y value. Now here the y value means the x, okay? Because fy is the y axis. So here the y is the x axis. So here we get, we go until 5. So -1, 0, 1, 2, 3, 4, and we'll go until 5. Actually, it's just a rough sketch here, okay? Okay, so at -1, what was the straight line from -1 to +1? 1 over 14, right? So this is 1 over 14, the first point, and then at +1, it's 3 over 14. Yeah, draw a line joining these two. And then from 1 to 3, right? From 1 to 3, it's 3 over 14, maintain. From 1 to 3, you maintain the 3 over 14. Do you agree? And then from 3 to 5, you start at F3, 3 over 14. F5 is again it's 1 over 14. Can you see? So you get a trapezium-like shape here. Is this clear? So this is the PDF, the sketch of the PDF. Okay. So sketch the probability density function for 2 marks. Okay. Part B, they say given that EY square is 131 over 20, find variance 2y minus 3. Okay, how do we find variance 2y minus 3? Part B, first thing is you need to find variance y. Who is variance y? Variance y is EY square minus EY whole thing square. So EY square is given to you as 131 over 12. EY is the mean, right? Now, if you look at this particular graph, again, do you see that this is what? 131 over 12, 21, sorry. Now, when you look at the, to get the EY value, do we really need to now, to get EY, we have to keep integrating and multiply except x, right? Normally, EX, we do except x integration, and that also you have 3 sections here, right? So then you will have to use except x twice. But do we really need to go like that over here? Just for this 2 marks, 4 marks here. You don't need to. Why? This graph is actually what? Can you see it's symmetric? It's symmetric. It's symmetric. So what's exactly the middle value here? 2. So yeah, EY is 2 because it's symmetric around 2. Are you with me? So you can start off by saying EY is actually equal to 2 because it's symmetric about the point 2, the entire graph. So EY is 2, so it's going to be 2 square. Can you all get me the answer for variance y? 131 over 12 minus 2. How much? 47 over 21. Okay, we are supposed to find what? Variance 2y minus 3. Okay, how do we get variance 2y minus 3? This is S1. In S1, you have learned variance AX plus B, how to expand the bracket. So when you have the variable with y, it becomes 2 square times variance y. Minus 3 doesn't come at all, the plus or minus. So this is a rule you learn in S1. Y AX plus B is equal to A square YX. This is something you learn in S1. EAX plus B and YAX plus B. Okay, so these are rules you learn in S1. These 2 rules. So we use this one. So this becomes 2 square times variance y. 2 square is 4 times variance y is 47 over 21. Can I know the answer? 188 over 21. Is that clear? Moving on to the next part. They say the okay, moving on to part C, they say the cumulative distribution function of y is Fy, capital Fy. Show that capital Fy equal 1 over 14, y square over 2 plus 2y plus 3 over 2 for y values between -1 to +1. Okay, how do we get the cumulative distribution function? So in cumulative distribution function, the whole purpose is that if you input a y value in between -1 and +1, it should give you the area start from the beginning, right? So for example, if you input your y as 1.5, sorry, 0.5, say, if you if you use y as 0.5, it means it needs to give you the area completely behind 0.5. So in this graph, this is the 0.5, right? So you have to get the area completely under 0.5 behind, okay? So how do we do that? Basically, the way we do here is we integrate, isn't it? To get capital Fx, to get capital Fy, we integrate. So here for the part C, to get capital Fy, we will integrate the simple Fy. The simple Fy is 1 over 14 times y plus 2, right? So we integrate with respect to y from where to where? The lower limit starts at -1. And for the upper limit, what are you going to use? Are we going to give +1? No, if you give +1, you will get the area completely between -1 to +1. We don't need that. We need to have a function in terms of y. So we will integrate from -1 to y, not x, because our variable is defined in terms of y. You will integrate your function from -1 to y, where y value can be anything in between -1 and +1. Are you with me? When you integrate 1/14, I'll take it out. Integration of y is y square over 2 plus integration of 2 is 2y. Are you with me? Your integration limits are from -1 to y. Let's input the limits 1/14 times. So I keep 1/14 out. First, you replace the y with y, so there's no change. In the second part, it's minus, and then you replace all the y values with -1. So -1 square over 2 plus 2 times -1. So what do we get here? 1/14 times this is y square over 2 plus 2y. Can I know the value here? -1 square over 2 plus 2 into -1, and whole thing is multiplied by a -1. How much is it? Inside the bracket, it's -3/2. So outside it becomes y square over 2 plus 2y plus 3/2. Are you with me? Which is the show that. So basically, if you use any y value between -1 and +1 and input it over here, what does it give you? It gives you the total area underneath that point, the cumulative probability. It gives you the area behind that particular point. Okay. So part C is done. Next one, part D, for 5 marks, they ask you to find capital F5 for all values of y. Okay, how do we find capital F5 for all values of y? Okay, so then go to the next part of the graph. Okay, so I took a copy of the graph over here so that we can refer it when we are doing. The next part is you have to get the capital Fy for 3/14 between -1 to +1. So what do we do in part D? So for y values between 1 and 3. So make sure you clearly identify from in which range you are working. How do we get capital Fy for y values between 1 and 3? So the integration will be for 3/14, right? You just have 3/14. You will integrate it from where to where? This is the 3/14. This part you will integrate it starting from 1, and your limit should be, upper limit should be y. Okay, so however in here, remember when you integrate from 1 to y, where y values are between 1 and 3, you will get what? You will get the area starting from 1 until whatever the y value in between 1 and 3 you give. So if you, for example, you give y is 2, then you get F2. F2 gives you here the area from 1 to 2 only. But is that what capital F2 is supposed to represent? No, capital, when I say capital F2, I mean to have the entire area behind 2. Not just the small part from 1 to, but the area from -1 until 2. Are you with me? So to get this answer, what should I do? Can you all suggest me the correction I need to do here? I have to add what? This is from -1 to y, and then this is dy. So this gives me the area only from 1 to any point that we give. So then because we need to get the area also behind this, we need to what? Add. We have to add capital F1. If I say capital F1, do you agree? Capital F1, we can get it from the earlier graph. Capital F1 from the earlier graph, we need to add it over here. So when capital F1 plus the area over here from 1 to whatever the y value we give gives us the total cumulative area behind the y value. Are you with me? So how much is this when we integrate? 3/14 when you integrate with respect to y, it's 3/14 y, right? So your limits are from 1 to y. And capital F1, can you all simplify? 1/14 times 1 square over 2 is 1. 2 times 1 is 2 plus 3/2. So this will be 3/14y minus 3/14 into 1 when you input the limits. And this is how much you said? This is 2/7. So 2/7 is the full area behind 1. So have a note of it. Huh? Capital F1 is 2/7. So that means the area between -1 to +1. This trapezium area is 2/7. Can you all add it all? 3/14y plus 1/14. So basically, if you use F2 here, now what happens? Because you have added the previous part, you will get the area from 1 to 2, and also this behind area is also already added to it. So you will get the total area from -1 to 2. Is that clear? So we are not done yet. There's another part to fix. The last part is the integration. You have to consider the region for y values between 3 to 5. So for y values between 3 to 5, fy. What are we integrating? The function is 1 over 14, 6 minus y, right? And from where the limit starts at 3, ends at y, where y value can be anything between 3 and 5. Okay, but it's not over because when you integrate from 3 to y, so you will only get from 3 and until whatever the y value, you will only get this area. But when you give capital F, whatever the value over here, say we give 4.5, capital F 4.5 is not supposed to just be this area, but the entire area behind. So what should we do? I have to add the capital F3. Capital F3 should be added to this part. Okay, so we will add capital F3. How do I find capital F3? From whom do I find capital F3? From the previous part, from this part, because this is already corrected. So I can use F3 over here and get the total area behind 3. Let's input this. 1 over 14, I'll take it out. What happens when you integrate? 6 integration is 6y. Y integration is y square over 2. Limits are from 3 to y. Capital F3. 3 over 14 into 3 plus 1 over 14. Are you with me? So 1 over 14 into how much is it? 6y minus y square over 2. And then minus, now you have to replace all your y values with 3. 6 times 3 minus 3 square over 2. Plus this is 9 over 14 plus 1 over 14, 10 over 14, which simplifies to give how much? In the calculator, it will give you a simple answer, right? 5 over 7. Okay. So let's simplify here. This is 1 over 14. 6y minus y square over 2. How much is this? Minus 27 over 2. Inside bracket 27 over 2 with the minus outside minus 27 over 2. We'll take 1 over 14. We'll take it in, right? We'll take it in. No, we need to add this. 27 over 2 is a constant and 5 over 7 is a constant. So we need to simplify this further. 1 over 14 into 6 is 3 over 7y minus 1 over 14 into minus half y square is 1 over 28y square. 1 over 14 into minus 27 over 2 is 27 over 28 plus there's a 5 over 7. We need to further simplify. What does it give you? 3 over 7y minus 1 over 28y square minus 27 over 28 plus 5 over 7. Can I know the answer? Minus 1 over 4. So this is your capital Fy completely defined. Okay, so then to completely define, it's not like this. You have to give the full thing under the, you have to give it, define it in this manner. Okay, starting from the first one. In between minus 1 to plus 1, what was the answer? That was the show that in part C, right? 1 over 14 y square. Can you all tell me? So first one is we write 0. 0 for what? For y value smaller than minus 1. Then the next one was 1 over 14. What was it? Y square over, yeah, tell me, y square over 2 plus 2y. This is defined for y values from where to where? Greater than or equal? Greater than minus 1? Less than or equal plus 1. So we can say this is y less than or equal minus 1 is 0. Okay, what was the next range? The next one was for y values between 1 and 3, right? For y values between 1 and 3, what was the capital Fy? 3 over 14y plus 1 over 14. This is defined for y values between 1 and 3. Okay, there's another part, right? For y values between 3 and 5. So for y value is between 3 and 5, 3 over 7y minus 1 over 28y square minus 1 over 4. So this is what? For y value is greater than 3. And then the last one, capital Fy is 1 for y value greater than 5. So this is the full, this is how we fully specify the cumulative density function. Is this clear? So this is how we fully specify it. Okay, next part. Part E, they ask you find the exact value of the 30th percentile of y. 30th percentile means what? 30th percentile means you have covered 30% of your area. Okay, so your first thing is you need to first understand in which region the east is staying, because to use capital Fy, we could use directly capital Fy is 30%. But the thing is you need to realize which region it lies in before you use it. So we need to do a little bit of thinking here. Can you all tell me? I think we got here capital F of 1 is 2 over 7, right? Previously in our calculation, can I know how much is it in decimal? 2 over 7 in decimal, because we got the area for capital F1. How much? 0.2857, which means 28.57 area is covered between -1 to +1. So that means I have a feeling that the 30% should come in the second part, right? So if you, I think if you check the F3, we got F3 answer as well, right? Here F3 answer was, capital F3 answer was 5 over 7, right? Can you see? Capital F3 answer was 5 over 7. How much is capital F3? 0.7143. Okay, 71428. So basically it covers, when you come to, by the time you reach capital F3, you have covered 71% of the area. 71.43% of area is covered by the time you reach 3. So that means 30% is what? By the time you reach F1, you have only 28%. You haven't reached 30%, which makes you realize what? 30% is in the second part. In this part, 30% is in between what? Your 30%, your 30th percentile is between 1 and 3. That's clear? So you realize your 30th percentile is between 1 and 3. And then in part E, you realize it's between 1 and 3. So capital Fy is 30%, 0.3, and you use what? You use the you realize it's between 1 and 3. So you use the respective equation. 3 over 14y plus 1 over 40 is equal to 0.3. And you find the y value. Who gives you that? So we'll use a different letter here. If M, 30th percentile is M, you can use some letter. How much is it? 3 over 14 M equal 0.3 minus 1 over 14. How much? Then how much is this? 0.3 minus 1 over 14 is 0.3 minus 1 over 14. How much? 0.3 minus 1 over 8 over 35. And then you bring the 14 up over 3. Final answer M gives you 16 over 15. And when you type 16 over 15 in the cal, does it give you a value between -1 and plus, between 1 and 3? Should, yeah, 1.0, because it's close to 1. You can see the earlier value of F1 was 28%. So 30% is quite close to 1. Half, but passing 1. Okay, then the last part. Find the probability for y is less than or equal 5, given that y is less than or equal 3. Okay. So again, we'll go with this part E. Can you all remind me the sum again? What is it? Probability for y is less than or equal 5, given that y is less than or equal 3. Okay. So first thing is that we go to the, I mean, this is a given that it's a conditional probability, right? First thing is 4y is less than or equal 5. In other words, y is less than or equal 5 over 4. Given y is less than 3, are you with me? So when you expand this bracket, given that A given B is A intersection B, right? Y less than 5 over 4 intersection y less than or equal 3, divide by the given that probability, y less than or equal 3. Are you with me? Part F, right? Sorry, yeah, part F. Okay, so now what's the intersection of y less than or equal 5 over 4 and y less than or equal 3? 5 over 4 is how much? 5 over 4 is some 1.25. So y less than or equal 1.25 and y less than or equal 3. What's the intersection of both of them? Y less than or equal 1.25 and y less than or equal 3. What's the intersection for both of them? Y less than or equal 1.25. We'll work with that. So intersection of them is y less than or equal 5 over 4 divided by y less than or equal 3. So to get the probability y less than or equal 1.25, to which region do I need to go to? Go to the this one. Go to between values between 1 and 3, right? Because 1.25 is between 1 and 3. So go over here, replace y with 5 over 4. So 3 over 14, y is 5 over 4 plus 1 over 14. Are you following what I'm doing here? I replace 5 over 4 into this region. Why did I replace it to this region? Because 5 over 4 is a y value, that's 1.25. 1.25 y value falls between 1 and 3. Which means if I want to find this is less than or equal means the cumulative probability. To find the cumulative probability, I have to go to the respective region. So this is the one and substitute y as 5 over 4. Y less than or equal 3, I believe we found it earlier as well, or else we can again come over here and just replace 3 over 14 into 3 plus 1 over 14, isn't it? Because we can get 3 here. 3 over 14 times 3 plus 1 over 14. I believe we found this earlier as well. Can I know how much is the top answer first? We'll get it part by part. The top part is 19 over 56. Divide by what was the bottom part? We got it previously also, 5 over 7. 19 over 56 divided by 5 over 7 is 19 over 40, which in other words, 0, yeah, so we can leave 19 over 40, 0.475. Or you can leave it as 19 over 40. Either answer is fine. Is this clear? Yes. So this is the end of the October 2021. Let's do it.